Welcome to another AQA A-Level Chemistry video. Today I'm going to be doing a video on carboxylic acids and esters, so I'm going to go straight into it. So carboxylic acids, they have some useful reactions, among them the neutralization and esterification. So if we're talking about the structure of it, so below is a molecule that contains the carboxylic acid functional group, which is the COOH, which is this here. The carboxylic acid functional group is example, and I have an example here, which is the butanoic acid, right? So 1, 2, 3, 4. So it's the alkyl chain, butan, and then oic acid, which is, this is the carboxylic acid functional group, right? Obviously there's a bond here between them. You don't have to write, you don't have to say butan, you don't have to say butan 1 oic acid, because always the functional group is always going to be on the first carbon there. So it isn't necessary in this case. It generally always takes prevalence. I don't believe there's any other compound that takes prevalence over it. But remember always to know naming conventions. I guess that's quite important. So it is an acid. It is acid in the name, so it has some acidic properties. So carboxylic acids they are acids, but they're weak acids, meaning that they only partially ionize in water or in solution, but the solution is usually water. They will react with carbonates to produce they will react with carbonates to produce carbon dioxide, and this will be used as a test for carboxylic acids. Yeah, so remember the test so I can remember I said there was a test to prove the presence of a carboxylic acid. You add your you add some sort of carbonate, calcium carbonate, whatever carbonate you want to add, and then you funnel the gas, because the CO2 gas will be formed. You funnel that gas over to lime water, and that will cause the lime water to turn cloudy. And then if it turns cloudy, you know that carboxylic acid was originally present in your original solution. Alright, so these are different things. So this is just general things about carboxylic acid. So the obviously, so yeah, I gave an example, the structure, the functional group, and a way to test them. Some general properties, right? And then there's esterification, which is something that carboxylic acids do. Carboxylic acids will react with alcohols, and this is generally called this is just called an esterification. It produces an ester. Usually would use sulfuric acid as a catalyst for this reaction. Now, you don't need the mechanism for this particular esterification example here, because I'm going to be going about sapification and in particular forming vegetable oils and fats, glycerol, all of that. So you don't have to know about that esterification, but you will need to learn about the nucleophilic addition elimination. Oh, what? That's wrong. Sorry about that. You will need to know about nucleophilic addition elimination reaction. I will go through that in a separate video. This isn't for today, but it's the actual mechanism between alcohols and carboxylic acids that actually forms the esters. And here's an example of what you need to know for this particular example here below, or just general understanding of how esters work. Carboxylic acid plus the alcohol, and then you get your ester. This would be a condensation reaction. Condensation usually means forming. Yes, I think condensation generally means forming. Yeah, it's a condensation product. The H2 obviously go. You get an OH. Either one of the OHs go. You're losing. Remember, you're just forming an O here, right? So OH and H has gone, and now you've just released water. I always forget. Is it condensation reactions that form water? There is. It's condensate. Yeah, I think it's called the condensation reaction. What's the opposite? I always forget what it's called. Hydrolysis. Yeah. So this is an hydrolysis. You're not using water to break this. You're forming water during this reaction. So this is a condensation reaction, because you can clearly see you're just left with this oxygen here that's acting as the part of the ester bond. This here, this COO C, or generally this is like kind of regarded as a COO C, right? That's generally regarded as your and obviously R, right? That's your ester. That's your ester function group, right? Up to here generally. I should have used a different. Anyways, I should have used R1. That's the actual function group there for the ester. All right. So structures of esters, right? So the esters formed from the reaction between an alcohol and a carboxylic acid will contain an ester functional group. Oh, as I said here. Why did I say C? Oh, that's already gonna be the R. I always knew there's still something wrong about this. COO and then R, right? As shown above. And this example in particular here is butyl butanoate. It's always your alcohol will be the butyl, will be the aryl part. So it'll be, in this case we use butanol, so it'll be butyl, and then your carboxylic acid, which is the because technically when you're kind of forming a carboxylate here, so you have a carboxylic acid can dissociate into, as I said before, one of the properties of carboxylic acids, they're weak acids, right? Which means they only partially ionize in solution. Which means they only partially dissociate into the H plus and an ion, which would be, all right, so you have this here, right? COOH. That's the functional group here. When it dissociates, COO minus and the H plus. So H plus obviously you know is going to be your is the obviously the acid part, right? Acid part in the solution that's causing acid is generally termed for acids, right? And this COO minus ion is called a carboxylate ion. So when you have COO minus, obviously you have the rest of it, like this here, right? This would be a carboxylate ion, right? That's what we call a carboxylate ion, and then we generally call this in general a carboxylate. And I said before, carboxylic acids are weak acids, so they don't do this often. There's very few molecules that would actually go and do this. Whereas HCl, you know, HCl is a very strong acid, fully dissociates in solution, and you in a solution of HCl, you never have a technical difficulty there. So, yeah, so you'll never so in a solution of HCl, right, you'll never find HCl like this. It's always going to be in its dissociated, say H plus and Cl minus, because it's such a strong acid, all of it just dissociates. Maybe there might be like one or two, but generally in solution it's just going to be HCl. So H plus and a Cl minus. And relating it back to this, and I've kind of gone off a bit off topic a little bit there. So this carboxylate here, is that's related to the butanoic acid. So this is a butanoate. We'll call this a butanoate ion. So you have and when you combine them together, your butanol and your butanoic acid, you have your butyl butanoate. There you go. So yeah, now I'm just gonna do a quick summary of everything we kind of gone through so far. I've gone through everything right now. Yeah, I'll just go. So yeah, so I just kind of go and do a little review of everything done so far. So reactions of carboxylic acids, right? I'll just write the functional group. So carboxylic acids, they can be involved in neutralization reactions, or they can be involved in esterification. So we're going to go through the neutralization part first, right? Neutralization reaction, they can react to partially, they partially ionize in solution, or in this case water. So partially ionize in solution, ionize or dissociate in solution, or they dissociate into ions. So I guess it's forming ions. And then the other feature is that they can react with carbonates to produce CO2. Reacts with carbonates to produce CO2. That's a horrible one there. And then lastly, that they can also, the other thing they do is esterification. Kind of overdone it there, have I? And they can react with alcohols to produce esters. That's just really it, to be honest. Reacts with alcohols to produce esters. Now, esters are, if I just go a bit into more to esters. So esters are very useful compounds, and they also occur in nature. Uses of esters, they, for example, are just to name a few, plasticizers. Did I go for plasticizers in? I must have gone for it in year one. And all they do is that they remember when I was talking about polymers. All plasticizers do, if you don't remember, they just go in between the polymer chains, and they prevent van der Waals intermolecular forces from occurring, or they just prevent intermolecular forces in general from occurring. And if you have less of those intermolecular forces, it's less rigid and less strong, so then it allows it to be more flexible. And usually using certain clothing to allow more flexible clothing, so the clothing isn't obviously too rigid and kind of like squished. But obviously when you wash your clothes, some of these plasticizers kind of go away into the water, and you notice that over time your clothes they're not as flexible as they used to. They're more harder than they used to be, and that's because they have a lot. That means your clothing has a lot of plasticizers, and that's all it is here. Downsides of plasticizers, if they go into the water, they are believed to be carcinogenic, because they go into the water stream, and then it's hard to kind of remove them, and that kind of thing. Solvents, they can use as solvents, like for example ethyl ethanoate. Perfumes is like the most, perfumes, colognes, any like kind of nice scent. That's what they're generally used for, and food flavoring as well. These two are like generally the most commonly used ones, I guess, or at least the ones that spring to mind the most, right? Biodiesel. So another thing to know about them is they can be used for biodiesels, and they're made up of methyl esters of long-chain carboxylic acids. The long-chain carboxylic acids are reacted with methanol to make the esters. Biodiesel is made by reacting vegetable oil with methanol in the presence of a